ENME 351, Lab 6, King Ralph. This code was used to control the servo motor position from the potentiometer input. T period describes the period length, and this value was adjusted to account for motor settings and the time it takes for the Arduino to cycle through the code. T control controls the duty cycle percentage of the pulse being sent to the servo. This value was adjusted for the motor. Because these adjustments are not 100% accurate, there is small deviation from optimal performance of the servo motor. After running the code, here we see the servo motor moving back and forth from 0 to 180 degrees based on the potentiometer input. We also see the T control being outputted to the screen along with the corresponding angle. To find the output voltages for an R2R DAC, we can apply Kirchhoff's current law to find the governing equations. After solving the system of equations, we find the equation for Vout, and this leads us to find all the values for the inputs of this DAC. We see that 0.625 volts is the least significant voltage. When simulated in Circuit Lab, we can test the outputs. These inputs are read from the least significant bit to the most significant bit. We see 001 gives an output of 2.5 volts. An input of 000 gives an output of 0 volts. An input of 011 gives an output of 3.75 volts. And an input of 010 gives an output of 1.25 volts. Here is the code to test the output of the DAC after building the circuit. Here is the table of inputs tested, and we see the physical circuit aligns well with the theory and simulation. If we needed smaller step sizes for the DAC, we could add more bits by adding more resistors to the circuit, or we could decrease the full-scale voltage. Now the servo is controlled from the output of the DAC. We see 5 different positions from the servo. This is different from the potentiometer because with the potentiometer, we see a continuous or analog position output. The DAC provides a stepped or discrete position output. If we needed smaller step sizes, we would need to add more resistors to add more bits to the DAC. More bits would get us closer to having an analog position output.